Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about real mode and protected mode that are available in the advanced microprocessor. Here, we are discussing now about advanced microprocessor. Coming to 80286 and 80386 microprocessors, they are advanced microprocessors which will be operating in different modes. So we need to discuss about each advanced microprocessor operating modes. So here the operating modes are real mode and protected mode. So coming to the advanced microprocessor, 80286 microprocessor, generally it will be operating in two modes. Here, the two operating modes are, one is real address mode and another operating mode is protected virtual memory address mode. Now, we will discuss in detail about these two operating modes of 80286 microprocessor. Now, when this 80286 microprocessor is operating in real address mode, this is one of the operating mode. When it is operating in this real address mode, the operation will be same as 8086 microprocessor. That means this 80286 will act as 8086 microprocessor only. So we know that in 8086 microprocessor, it consists of 20 address lines. 20 address lines are there in 8086 microprocessor. So when this 80286 is operating in this real address mode, it will be same as 8086 microprocessor. That means only 20 address lines will be used. So here, that is why 1 MB physical memory will be used by 80286 when it is operating in this real address mode. Why? Because it also consists of 20 address lines. If you write this 2 power 20, it leads to 1 MB physical memory. So that is why it uses only 1 MB physical memory. Now, the second operating mode is protected virtual memory address mode. So when 80286 microprocessor is operating in the protected virtual memory address mode, its operation will be different. That means it will use 16 MB of physical memory and it uses 1 GB of virtual memory. Now, so since this is the real and protected modes of operation, here when this advanced microprocessor are operating in different modes, calculation of physical address will be different. That is why before going to the operating modes discussion in detail, first we should know what is meant by physical address. To calculate physical address, how we are using this segment address and offset address. So first, what is meant by physical address? Here, physical address, it is the address where actually the operand is resided. So the microprocessor generally fetches the instructions based on that address only. Okay. So here the physical address means it is a location. It is a location where actually the operand resided. Okay. So here based on this physical address, so here based on this physical address, the microprocessor is going to fetch the instructions, from memory. Okay. So generally if we consider 8086 microprocessor, it consists of 1 MB physical memory. So here, this 1 MB physical memory is divided into 16 logical segments. It is divided into 16 logical segments. Each segment is of 64 KB. Okay. Now, so to calculate physical address, we will consider segment address and offset address. So first we should know what is meant by segment address. So here generally, if we consider 8086 microprocessor or 80286 microprocessor, the segment registers that are available are code segment, stack segment, data segment and extra segment. So the segment address represents the starting address of each segment. So here segment address indicates beginning address of 64 KB memory segment. So this is the beginning address. So each 1 MB physical memory is divided into 16 logical segments. Each segment is of 64 KB. So this segment address will define the beginning address of each 64 memory segment. Now coming to the next one, it is offset address. So here this offset address indicates the address value with anywhere within 64 KB. So here offset address selects any location within 64 KB memory segment. Okay. So here segment address indicates beginning address of each 64 KB memory, whereas the offset address indicates any location within 64 KB. So here these are the parameters that are required in order to discuss real mode and protected mode operating modes. Now, so 80286 microprocessor is having two operating modes. One is real address mode. So when it is operating in the real address mode, it acts as 8086 microprocessor, but fast 8086 microprocessor. That means the operation of this 80286 microprocessor will be 6 times faster than 8086 microprocessor. And also, memory management and protection mechanisms are disabled. Here, you will not have any memory management and protection management mechanism. Why? Because when 80286 is operating in the real address mode, the operation will be same as 8086 microprocessor. So that is why these memory management and protection mechanism will be disabled. 80286 is object code compatible. So generally, there will be source code and object code. Source code means it will be written by a programmer, whereas the object code means when that source code is compiled, then the code that is generated is called object code. So here, object code means it is produced when source code is compiled. When source code is compiled. Now, another operating mode of 80286 is protected virtual address mode. So when 80286 is operating in this mode, 80286, when it is operating in this mode, we will have this memory management mechanism and also protection capabilities will be enabled. Along with that, 80286 microprocessor will have advanced instruction set. So in the protected virtual address mode, 80286 microprocessor is source code compatible. So here generally, what is meant by source code means it is a program written by a programmer. Okay. So here source code means it is written by programmer. Okay. So these are the two operating modes of 80286 microprocessor. Now, so when 80286 microprocessor is operating in protected virtual memory address mode, along with some amount of physical memory, it is also using virtual memory. So we should know first what is meant by virtual memory. So here, virtual memory is a part of hard disk which is used to store large instructions. So this extra memory that can be addressed by a computer other than physical memory is known as virtual memory. Suppose here there will be some instructions which need to be loaded in a memory, but actually their sizes may be greater than the provided physical memory. So in such cases, we have to use the virtual memory, that is, we have to use a part of hard disk in order to execute that large instructions, which is known as virtual memory. So simply to say, virtual memory is an additional memory which we are taking from a hard disk in order to execute large instructions. Now, so 80286 microprocessor, when it is operating in the real address mode, it acts as same 8086 microprocessor only. Okay. So according to the features of 8086 microprocessor, we know that it is having only 20-bit address bus. It has only 20-bit address bus. So that is why only 20-bit physical address is generated. 20-bit physical address is generated. Okay. So 20-bit physical address will be generated. Now coming to real address mode, here it will be generating 20-bit physical address. But coming to here, in order to generate 20-bit physical address, we have learned how to calculate. That is, considering the segment address, making that into 10. Because in order to make 4 bits shift towards left side, and to that value, we have to add the offset address. So together gives 20-bit physical address. So here we have offset address, and here we are having segment address. So if you are adding this offset address with the segment address, it is going to give 20-bit physical address. Now, so as we said, calculation of physical address when it is operating in the real mode is same as 8086 microprocessor. Now we will see what is the procedure we have to follow to calculate the physical address when it is operating in the real address mode. Now, so in this case, consider an example. So for example, consider the segment address as 1005H that is given, and consider the offset address that is given as 5555H. Okay. So considering the segment address and offset address, both are 16 bits, we have to generate 20-bit physical address when 80286 microprocessor is operating in the real address mode. Now, same procedure we can follow how we have calculated the physical address in 8086 microprocessor. Like, consider the segment address. So here the segment address given is 1005. We have to write this value in terms of binary. So the value of 1 is 0001, and the value of 00 is 0000 and 0000. And here the value of 5 is 101. First we have to shift this value 4 bits towards left. So if we shift the value 4 bits towards left, what happens means, so this is the left shift. So if we are shifting 0001, 0000, 0000, and this is 0101. So the last 4 bits will be vacant. So the last 4 bits will be filled with zeros. That is 0000. Now, consider this as a segment address. To this segment address, we have to add the offset address. Okay. So here the offset address given is 5555H. So this offset address first we have to write in the form of binary. So here the value of 5 is 0101 and another 5 is 0101 and next again 5 is there 0101 and for the next 5 0101. Now we have to add this. If we add, so here 1 0 1 0 and next here 1 0 1, this is 1 0 1 and next 1 0 1 0. If we add 0 0 1 0 and next we will get 0 0 0 1. Now we have to convert these values into hexadecimal values. So the value of 0001 is 1 and 0101 is 5 and 0101 is 5 and this is 1010. Its value is generally 10. In hexadecimal it will be represented as A and 0101 its value is 5. Okay. So the physical address is 155A5H. Or so we can, this is one procedure where the 20-bit physical address is generated when 80286 microprocessor is operating in the real mode. Or another procedure we can follow here is simply going for the formula segment address into 10 plus offset address. Okay. So any one procedure we can follow in order to calculate 20-bit physical address when 80286 is operating in the real address mode. And here, so when it is operating in real address mode, that is 80286, it acts as fast 8086 microprocessor. So it uses only 20 address lines. Generally, 80286 microprocessor address bus size is 24-bit, but when it is operating in the real address mode, it uses only 20-bit. So that is why here the physical memory size will be 1 MB because it will be 2 power 20. This 20 represents the number of address lines. So generally here 80286 microprocessor, it is having 24-bit address bus. But when it is operating in the real address mode, it uses only 20 address lines among 24 address lines. So that is why only 1 MB physical memory will be used. Next, so the real address mode of operation is same as 8086, but it will be faster, 6 times faster. Okay. So the instruction set is compatible with 8086 microprocessor. That means if you want to write any assembly level language programming for 80286 microprocessor, we can use the same instruction set that is present in 8086 microprocessor. Now, so here when it is operating in the real mode, it uses only 20 address lines and 1 MB physical memory. Whereas the address lines that is from A20 to A23 are not used by the internal circuit of 80286 microprocessor in this mode, because here the address bus size is 24-bit. When it is operating in this mode, these address lines will not be used. And So when it is operating in this mode, it is going to use only A0 to A19 by using this BHE signal. So here BHE represents bus high enable. So that is why it is using only 20-bit address lines. So only 20-bit physical address will be generated, same as we have discussed in 8086. Now, another mode of operation 80286 has is protected virtual address mode. So here protected virtual address mode represents simply PVAM. It can be represented as PVAM. When this 80286 is operating in the protected virtual address mode, it is going to generate a 24-bit physical address. So this physical address calculation is different. It is not same as 8086. The physical address calculation is different here. So here the address lines that is available in 80286 microprocessor is 24 address lines. So all these address lines will be used in order to generate 24-bit physical address. So when this 80286 is operating in the protected virtual address mode, which is called PVAM, here this is the 32-bit virtual address. This 32-bit will be divided into 16-bit selector and 16-bit offset. Okay. So from this 16-bit selector only, we are going to get the segment address. So anyway, to calculate the physical address in any mode, we require segment address and offset address. In this PVAM mode, offset address will be getting from this 16-bit offset directly, but whereas the segment address will be getting from this 16-bit selector. And here, this 16-bit selector, again it is divided into 13-bit index and TI, 1-bit TI and 2-bit RPL. So here, there is TI. So here, TI represents table indicator. TI represents table indicator, whereas here we have RPL. So here RPL represents requested privilege level. Requested privilege level. Okay, so this is requested privilege level. So totally the 16 bits are divided into 13-bit index, 1-bit table indicator and 2-bit request privilege level. Now, so this TI is the deciding bit. This bit only decides whether to select this global descriptor table or local descriptor table. Now, so if this TI bit is 0, this global descriptor table will be selected in order to generate the segment address. If TI is equal to 1, this local descriptor table will be selected in order to generate the segment address. So if TI is 0, the segment address will be coming from here. If TI is equal to 1, the segment address will be coming from here. Only one descriptor table will be activated based on this TI bit. Okay, any one of this descriptor table will produce the segment address. So it is going to generate this 24-bit address, which is called segment address. Okay. So now segment address will be coming from here and offset address will be directly from this. It is of 16-bit in size. So segment address plus offset address, it is going to generate physical address which is of 24-bit size. Why? Because here segment address is 24-bit and also and this offset address is 16-bit. So segment address plus offset address gives 24-bit physical address. Now, so protected virtual address mode, it is 32-bit address is called virtual address. And so we have just seen the figure. It consists of 16-bit selector and 16-bit offset. And the 16-bit selector block, it is divided into 13-bit index, 1-bit table indicator, and 2-bit requested privilege level. So based on this table indicator only, the descriptor table, local descriptor table or global descriptor table will be selected, which gives the segment address, 24-bit in size. So if TI represents here table indicator. If TI is equal to 0, this GDT. So here GDT stands for global descriptor table. Okay. So if TI is equal to 0, GDT is used as a lookup table. If TI is equal to 1, LDT will be used as a lookup table. So here LDT stands for local descriptor table. Okay. So here this GDT and LDT, they will be generally used for segmentation purpose. Now, so based on this, the 24-bit physical address will be generated by 80286 microprocessor by taking 24-bit base address and 16-bit offset address. And so while calculating the physical address, here in the protected virtual address mode, based on the TI bit, so here TI represents table indicator. Based on the TI bit, that is TI is equal to 0 or TI is equal to 1, in order to generate the segment address, global descriptor table or local descriptor table will be selected. So here this GDT stands for global descriptor table, and here LDT stands for local descriptor table. Okay. So here generally what is meant by GDT means it is one of the data structure that consists of some parameters like size. Okay. So here it is a data segment. It is a data structure to define characteristic. It is a data structure which is used to define a characteristics of various memory areas used during programming. Used during program execution, including, okay. So here including, what are all the characteristics here means, it represents address, size of the memory. Okay. So including address, size of the memory. So all these characteristics can be indicated in the global descriptor table. Okay. Now coming to local descriptor table. Here, so what is meant by local descriptor table means it is also a memory table which is going to define some characteristics. Okay. So it is a memory table. It is a memory table used in protected mode and contain memory segment descriptors. So here descriptors like memory, size, etc. So these are the basic differences between this GDT and LDT. Now, so those are the two operating modes of 80286 microprocessor. Coming to the next advanced microprocessor, that is 80386 microprocessor. So this 80386 microprocessor will be operating in 3 modes. So here the 3 modes of operation are, one is real mode, protected virtual address mode, and another one is virtual mode. So these are the 3 operating modes of 80386 microprocessor. Now we will discuss about these 3 operating modes in detail. Now, when this 80386 microprocessor is reset, it will be operating in the real mode. So if 80386 microprocessor or 80286 microprocessor, if they are operating in the real mode, the operation will be same as 8086 microprocessor, but faster 8086 microprocessor. So the main purpose of this real address mode is to initialize the system for protected virtual address mode. Now, when this 80386 microprocessor is operating in the protected virtual address mode, it works as normal 32-bit microprocessor. So coming to the basic features of 80386 microprocessor, its address bus size is 32-bit. So that is why if it is operating in the real address mode, it is going to use only 20-bit processor. But when it is operating in the protected virtual address mode, it is going to use 32-bit address bus that is present in the processor. Now, the third operating mode is virtual mode. When this 80386 is operating in the virtual mode, it allows the programmer to execute 8086 applications without disturbing the mechanism of protected virtual address mode. So when it is operating in the virtual mode, this 80386 microprocessor is going to execute all the applications of 8086 microprocessor. After executing all the instructions, again it will return to protected virtual address mode only. So these are the 3 operating modes of 80386 microprocessor. Now, so we will discuss about the 3 addressing modes. First addressing mode, that is operating mode of 80386 microprocessor, is real address mode. When this 80386 microprocessor is reset, it will be operating in the real address mode. That means the operation will be same as 8086 microprocessor. Among 32-bit address lines, it uses only 20 address lines. So it is operation will be same as 8086, but it accesses all the 32-bit registers. Here, all the registers that are available in this 80386 microprocessor are extended registers. Because each register size is 32-bit, they are called extended registers. Now, so here another name of real address mode we can call as default mode, and operand size will be 16-bit. Though the operand size is 16-bit, it uses 32-bit registers. And when 80386 microprocessor is operating in the real address mode, paging will be disabled and the processor can access 1 MB of physical memory using A0 to A19. That means when it is operating in the real address mode, the operation will be same as 8086 microprocessor. So 8086 microprocessor has only 20 address lines. So that is why it uses only address lines from A0 to A19, though it is having 32-bit address lines. And so since it uses only 20 address lines, it represents 1 MB physical memory usage. And so how to calculate the physical address for this 80386 microprocessor when it is operating in the real address mode means, the physical address calculation will be same as how we have calculated the physical address for 8086 microprocessor. Now, so in the real address mode, the size of memory segments will be 64 KB and the segments can be overlapped like 8086 microprocessor. So we will discuss about the segmentation concept also. And so in real address mode, two memory areas are reserved. Why these two memory areas are reserved means one memory for system initialization and another memory for interrupt pointer table. Now, so the primary purpose of operating this 80386 microprocessor in the real address mode is to set this 80386 microprocessor into protected virtual address mode of operation, which is called PVAM mode. Now, so this is the schematic diagram how to calculate the physical address for 80386 microprocessor. Now considering here, this is the offset address 16-bit and this is the segment selector which gives the 20-bit segment address. By adding this segment address and offset address, it is going to give a 20-bit physical address. So here it is going to use only 64 KB of physical memory. So in this way, physical address calculation will be done in the real address mode. And another operating mode of this 80386 microprocessor is PVAM. So here PVAM stands for Protected Virtual Address Mode. So when it is operating in this PVAM mode, it is going to use all the 32 address lines. So here, when the processor is operating in this mode, it has very large address space and also it supports all the softwares that are written by 80286 and 80386 microprocessor. So here coming to 80386 microprocessor, we will have segmentation unit and paging unit available. These two units gives efficient memory management mechanism. When this 80386 is operating in the protected virtual address mode, it is going to use 4 GB of physical memory and along with that, it uses 64 terabytes of virtual memory address space. Now, when this 80386 microprocessor is operating in the protected virtual memory address mode, it uses all the 32 address lines that are available in the 80386 microprocessor. So here, along with the 32 address lines, it also uses 4 select bank signals. So here, this is BE0 to BE3. These 4 signals are used for selecting the bank. Okay, and it also uses 4 GB of physical memory to address. And so 80386 microprocessor supports 2 methods for converting virtual address into physical address. Now, so here we are saying 2 methods are used to convert virtual address into physical address. So what are the 2 methods means? Here the first method is by disabling the paging unit. So I told you in 80386 microprocessor, we will have segmentation unit and paging unit. Okay, so this virtual address can be converted into physical address by disabling the paging unit and also it can be calculated by enabling the paging unit. So in method 1, paging unit will be disabled and physical address is calculated by using selector, descriptor and offset values like how we have calculated in 80286. By using the same parameters, the physical address can be calculated by disabling the paging technique. And Another method to convert virtual address into physical address is by enabling the paging unit. And a linear address is computed by using selector, descriptor and offset. So in the previous case also, by using these three parameters only, the physical address is calculated. In the second method, that is when paging is enabled also, in order to calculate the physical address, we are going to use the same three parameters to calculate the physical address. So these are the two methods we will use to convert virtual address into physical address. Now, so two methods are there to convert the address. One method is by disabling the paging. Okay, so this is the case where paging unit is disabled. Okay, so here we will not have any paging unit. So here we have offset address. To calculate the physical address, we require segment address and offset address. Okay, so from here we are going to have the offset address. Segment address will be coming from this selector. Selector consists of three parameters like access rights, limits and base address. So these three together gives the segment address. By adding the offset address and segment address, it is going to give the physical address. Okay. Now, so here this will be using only 4 GB of memory that is available in the physical memory. So this is how we have to calculate the or convert the address. This is the case where paging unit is disabled. And another method to convert is by enabling the paging unit. So here, this is the paging unit. This is the paging unit and it is enabled. This is the second method. So here when paging unit is enabled, generally what is the main purpose of this paging unit is, it converts linear address into physical address. Previous case, paging unit is not used, so linear address will be same as physical address. So here, generally CPU will be producing the logical address. Logical address will be converted into linear address by using segmentation unit, and that linear address will be converted into physical address by using this paging unit. Same, here also we are going to get the offset address from this offset value, and segment address we are going to get from this segment descriptor using the parameters like access rights, limits and base address. So these two together, if we add, it is going to get the linear address. If that linear address is given as input to this paging unit, it is going to convert linear address into physical address. And this physical address will be using this 4 kilobytes of physical memory. Okay. Now, how to convert this logical address to physical address means, generally here this is the CPU which will be producing the logical address. This logical address will be converted into linear address with the help of this segmentation unit, and this linear address will be converted into physical address with the help of this paging unit. And with this physical address, we are going to fetch the instruction that is available in this physical memory. Okay. So in order to find two methods, one is disabling this paging unit and enabling this paging unit. Okay. So if the paging unit is disabled, then linear address is same as the physical address. Okay. So if no paging is used, linear address will be equal to physical address. No conversion is done. And the third operating mode of 80386 microprocessor is virtual mode. Okay. So generally when this 80386 microprocessor is operating in the virtual mode, it is going to execute all the applications of 8086 microprocessor. Okay. So it can execute all the applications of 8086 microprocessor when it is operating in the virtual mode. Now, so when it is operating in the virtual mode, we will have the memory management section. It supports virtual memory, paging, and 4 levels of protection. So here 4 level protection mechanism is available. Okay. So paging enables to organize the available physical memory into pages of 4 kilobytes each. Just we have seen. So paging is a technique which is going to divide the entire physical memory into fixed size pages. Each page size is of 4 kilobytes under segmented memory. Now, so the processor can switch from protected virtual address mode to the virtual mode by setting a VM bit in the flag register to 1. So in the previous sessions, we have discussed about the flag register of 80386 microprocessor. Among different flags, this VM is one of the flag bit which says the virtual mode. So if this VM bit is fixed to 1, then the microprocessor, that is 80386 microprocessor, will be switching from this protected virtual address mode to virtual mode. So we can switch from one mode to another mode by simply setting the flag register bit VM to 1. Now, so in the virtual mode, the segment registers are used similar to the real mode. So here in this 80386 microprocessor also, we have 4 segment registers, that is code segment, stack segment, data segment and extra segment. Okay. So when it is operating in the virtual mode, it can use the same 4 segment registers as how we have used in 8086 microprocessor. Now, so in virtual mode, paging can be enabled. So what is the main purpose of this paging means? Multiple operations and multi-users. Okay, so this capacity can be achieved so that if paging is enabled, multiple modes or multiple tasks can be executed by multi-users. So with the help of this paging enabling, we can provide the protection and operating system isolation. So this is the main purpose of enabling the paging unit. Now, so here when paging is enabled, the 20-bit linear address can be divided into 256 pages. So when they are divided into pages, each page size will be 4 KB in the physical memory. So here the main difference between the segmentation unit and paging unit is segmentation, it is going to divide the physical memory into segments. The segment size will be variable, whereas the paging unit is going to divide the physical memory into fixed size pages. Each page size is of 4 KB. Now, so here 80386 microprocessor, when it is operating in the virtual mode, so if we consider here, this is the physical memory. Multi-tasks can be executed by using this physical memory when this 80386 microprocessor is operating in the virtual mode. So each paging capacity is around 4 KB only. So if you see here, this is task 1 and this is task 2. Okay. 2 tasks consist of different parameters. These 2 tasks can be sharing this physical memory. Okay. So multi-tasks can be performed by using the same physical memory. So this is how the 80386 microprocessor will be operating during virtual mode. So these are the different operating modes of advanced microprocessor 80286 and 80386 microprocessor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.